Physics Part 39. Now it's your turn. A value of the volume of V of a cylinder is determined to measuring the radius R and the length L. The relation between VR and L is V is equal to pi R square L. In an experiment, R was measured as 3.30 plus minus 0.05 cm. L was measured 25.4 plus minus 0.4 centimeter. Find the value of the V and the uncertainty of this value. If you find it difficult to deal with the fractional uncertainty rule, you can easily estimate the uncertainty of substituting extreme values into the equation. For x is equal to a, y, a, z, b, taking account of the uncertainties in y and z, the lowest value of x is given by x low is equal to ay minus delta y a. Z minus delta z put to a value of b. And the highest x high is equal to ay plus delta y a, z plus delta z b. If x low and x high are worked out, the uncertainty is the value of the x given by x high minus x low divided by 2. Example: apply the extreme value method to the data for the simple pendulum experiment in example. Because of the form of the equation for G, the lowest value for G will be obtained if the lowest value of L and the highest value of T are substituted. This gives G low, which is equal to 4 pi square 0.53 1.52 square is equal to 9.1 meter per second power raised to minus 2. The highest value for G is obtained by substituting the highest value for L and the lowest value for T. This gives G high is equal to 4 pi square 0.57 over 1.48 square is equal to 10.3 meter per second power raised to minus 2. The uncertainty in the value of G is thus G high minus G low into 2 divided by 2 is equal to 10.3 minus 9.1 divided by 2, 0.6 ms power raised to minus 2 as before. Now it's your turn. Apply the extreme value method to date for the volume of the cylinder at the top of this page. Well, we've got a summary for this section. Number 1, accuracy is concerned with how close a reading is to its true value. Number 2, precision is the part of the accuracy which can be controlled by the experimenter. Number 3, uncertainty indicates the range of values within which a measurement is likely to lie. Number 4, a systematic uncertainty or systematic error is often due to instrumental causes and results in all readings being above or below the true value. It cannot be eliminated by averaging. Number 5, a random uncertainty or random error is due to the scatter of the readings around the true value. It may be reduced by repeating a reading and averaging, or by plotting a graph and taking a best fit line. Number 6, combining uncertainties. For expression of the form x is equal to y plus z or x is equal to y minus z, the overall uncertainty is delta x is equal to delta y plus delta z. For expression of the form x is equal to A by A ZB. The overall fractional uncertainty is delta x over x is equal to A delta y over y plus B delta z L Z.